Menace is back. Oh, and Farmer's Boy. Right.
Hello. Yeah, I got fed up listening to Runty.
Oh, well, actually, I see you starting to get a little bit interested in it, actually.
No, he just rage quit.
Did he?
Well, it basically Mick West said, "Well, look, there's no point us talking because you're not gonna accept anything I say, are you?" And he said, "No." And he said, "Right, okay, goodbye then." I mean, he had a point. Absolutely nothing Mick West said was making any difference to Ranty whatsoever. So what's the fucking point in talking to him?
Yeah, he wasn't in a sort of monologuing mode, wasn't he? He was just allowing a little word from Mick, then would make another little statement, and then another little word from Mick. It was as though he was ready to quit. He was building up to quitting and getting all frustrated with the fact that Mick was saying basically, yes, you can account for most things with refraction. And he couldn't understand the difference between something that was compatible with refraction and other things that weren't. And therefore, it wasn't as though he was just saying, whatever you show me, I can account for it with refraction. But if you show something from the real world, and you've got a model of the real world that works, everything you show is going to match it. So,
quite.
So everything I show you, you're just going to say is refraction. Yes, because that's what the real world does.
It does.
Yeah. And while Ranty's saying that, he's showing two different pictures with two different amounts of viewable area.
Yeah.
He himself is showing refraction.
And it varies, yeah. Yes, I mean, I think he's trying to claim. I still haven't analysed those pictures properly, but I think he's trying to claim that you're seeing more than you're seeing down to the beach, and there are no circumstances. Yeah, it's because he's right. He has got some unusual conditions, Ranty, in that particular case. He's got some cold water and some warm air, and that gives you this sort of superlooming condition where you get lots of. Well, actually, no, that's not correct. Actually. The condition he's got there, I haven't analysed because he's got inferior mirages on that one, hasn't he? So he's not going to get super looming. Okay, I'd have to analyse. I still haven't analysed those pictures properly, but yes, you can't have inferior mirages with super looming. Yes, okay, but Mick's Earth curve calculator doesn't do all the refraction conditions, of course. It just does the simple standard refraction case, and so his Earth curve calculator. So what Rant is saying is, oh look, your Earth curve calculator says you shouldn't be able to see this, and then Mick West has put in that qualifier saying that it can't account for everything if you're looking close to the horizon. And then Rant is getting all annoyed, saying, "Oh look, your Earth curve calculator says I shouldn't be able to see what I'm seeing, and I'm seeing therefore a whole flat Earth model is wrong." And Mick West is then going back and saying, "Well, I didn't watch it all, so I presume what he said is," and putting that little red line is effectively saying this Earth curve calculator can't cope with all refraction conditions, whereas Rant is saying, "Oh, it should cope with all refraction conditions," and it's not. And so he's getting really annoyed.
How can it? How can his calculator know exactly what refraction conditions you've got on that particular day, given that Rant is in the habit of going out and finding the worst possible types of conditions to take fucking photos?
And what's more, he gets right on the ground where you get these.
Yeah, he is deliberately making it as bad as he possibly can. Correct. And then going, "Oh well, look at all of these effects." Well, yeah, that's because you're going out your bloody way to find them in the first place.
Exactly. When you get near the surface of the water, when you get as low as he does, you're going to get these peculiar, which can only be modelled successfully with ray tracing, which is what Philip and I have done. Yep. You can't do it with a simple calculator that Mick West has done. Although Mick West, as I see, he's done something in the last 6 months or so. He did this refraction thingy, which allows you to put in conditions, which enables you to change it slightly, but it's still not as good as a ray tracer, which you would need to do to really model the real world properly.
Well, but I mean, if you were being honest about this, and if Ranty was being honest about this, if you want to take photos over the water, you'd get at least 20 or 30 feet up. You'd go and find a cliff or something, to get you out of that god-awful area immediately above the water, to obviate all of these problems. But of course, he doesn't want to do that because he wants it to be as messy and fucked up as possible. So he can say, "Oh, look, it's the angle of attack and dirty air and it
invalidates the Earth curve calculator."
Yeah,
that's what he's trying to do. He's trying to find conditions that invalidate the Earth curve calculator, and indeed, because the Earth curve calculator is quite a simple calculator, and it doesn't have it just deals with standard refraction. It doesn't have all the pressure and temperature conditions that you can put into, and it's not a ray tracer, so it's limited as to what it can do. So if you start stressing the situation by going out on strange days, if you go out every single day, you're going to find one of these strange days with cold water, warm air, which means you're going to get increased refraction, you're going to get increased looming, And
Yep.
if you go low as well, you're going to amplify that problem. And so the poor old Earth curve calculator can't cope with all that. And then he wants to invalidate the Earth curve calculator, but that doesn't mean to say you're invalidating the spherical Earth model. All it means is you're invalidating that particular simple Earth curve calculator. And now he hates the fact that Mick West recognizes that it's just a simple Earth curve calculator. It's being stressed by people like Ranty, putting into it. If you start going, effectively saying, if you start going to very stressful conditions or unusual conditions, this Earth curve calculator can't give you decent results. And that's what Ranty hates, because then he then would say, oh, you're just going to claim then whatever happens, happens. Yes, it's only a simple calculator. You can't make it try and emulate the real world. The real world's really tricky. And so he hates
my stapler won't make a cup of tea for me, you know.
Yeah. Miss that, Khaled. Sorry, you're a bit distorted. Sorry, Khaled, say again.
You got a shout out from Rizzo Fiske.
On Mick West thing.
No, I'm not sure. In the chat here.
Oh, the chat here. Oh, right. Okay.
You.
What's he shouting? Is he complaining at me or something? I haven't got. Where's the link to the? I haven't got a link to the actual. I can't see it because I haven't got a link to the. Let me just hold on. Let me just get myself a link to your.
I hadn't opened it up either.
YouTube was it? And let's get. On your Crow X, aren't you? I am subscribed to you now, so.
You mean you weren't?
Coder, I just have to have you here, Coder.
Oh, I misspelled you, sorry. God. Oh. There we go. How long did you go? How long did you go on yesterday? There we go. Oh, this is we're testing one another again, aren't we? This is test 3. Oh, come on. Bloody thing.
Rumpus, when I was failing to contact you or to talk to you in the first trial or Hangouts, you were typing on the keyboard and it was horrible.
Sorry, what was horrible?
You're typing on the keyboard. It was so loud and so fast.
Have you ever heard GeoStreamer?
No.
GeoStreamer took his keyboard apart and put in a different set of keys, and you really can hear it. And he types at a furious speed, and it's like clatter, 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 clatter. And if there's a Hangout on and GeoStreamer's in it, as soon as you hear that noise, you think, "Yep, he's typing," because he totally rebuilt his keyboard to make it sort of more mechanical. I can't remember what he actually did to it, but my God, it makes a racket.
But normally in Hangouts, it mutes you if you start typing. Is it not doing that anymore? Sorry.
What? Hang on.
Yeah, I can hear. No, sorry. Now, what do I think? Yes. Yeah, sorry. Oh, right. But I said, but only if I type and talk. No, just no. Hold on. Yes, if you type it. It normally used to mute you in Hangouts. Why is it not? Okay, so it's not doing that anymore, is it? Okay. Okay, I'm confused. Yes, I'm confused. Okay, sorry. Sorry if I was typing like I normally in Hangouts it used to mute it when you type. I don't quite understand that. Okay, well perhaps. Sorry about that. Oops. Right.
That's right. Some people typing can get a bit frantic sometimes, but I know GeoStreamer's the worst of the lot.
Yes,
but that's because he's got a fairly unique keyboard, I think.
That's right. He reconditioned the keyboard. He pulled it all apart. He put it in he boiled it away to get rid of all the yellow staining to restore it to the original colours. He put it in an acidic solution or something to get rid of all the yellowing, and then rebuilt it all. Yeah. So indeed he right. I'm just astounded because I've always been in Hangouts when I've typed. I've got used to that. I know Discord didn't do it, and I know that the new meetings one doesn't do it, but I always thought old Hangouts did, so I'm okay. All right. Okay, but hold on, you must have been able to hear me typing then. So hold on, Callie, you saying that you couldn't hear me typing, but when it went on the stream? I'm confused now.
I could hear you typing.
Oh, you could hear me. Okay, well, if you can do that, then yeah, if I'm making a real racket, then yes, let me know and I'll stop. Yeah, George was going to come in here, wasn't he, and talk about this video that we were referencing yesterday and about relativity.
Don't think he's going to.
Oh, right, isn't he? Oh, okay.
No, he posted on Skype, no time to discuss in detail today.
Oh, that's right.
Maybe for a bit though. Oh, make your mind up then.
Yeah, because I've got yes, and I'd say I'm desperate to watch. There's quite a lot of, as anybody's British would know, we're having a bit of a rumpus at the moment in the political world, and I keep a Brexit and everything, and we've got.
I haven't the faintest idea what's fucking going on with that. I mean, it's just, if Brexit wasn't bad enough, we've now got them fighting over who's going to be the next prime minister. It's like, I don't want either of them idiots. You know? Yeah.
So people who don't know anything about what's going on may have heard of Brexit. We've got rid of our horrendously appalling supine Theresa May prime minister, who basically negotiated an appalling agreement with the EU. We finally got rid of her a few weeks ago when she finally resigned when she couldn't get the legislation through for her form of Brexit. Now we kicked her out, and we're in the process of electing now the members of the Conservative Party, which is the leading party in this country, and the one in government, electing a new leader, and then to take us through to this Brexit period on October the 31st. We're going to leave according to the current situation, and then and that's
both candidates are a complete and utter muppet.
Well, I must admit, I'm just now want a candidate that's going to get us out by the time. I'm just fed up with the supine stuff. So it's all happening here politically. So probably most of the people listening on it.
I need a minute, please, just to apologize to the people in the chat. George may not come, and this Hangouts is just random, so you can go on your way if you like to. This is nothing coherent we're going to talk about. Thank you.
The random ones are always the best ones.
We were going to do a relativity thing. You could put in the link. We could have said we were going to discuss that relativity video that they might be interested in seeing that girl in the relativity video that I was showing the other day, where George is claiming there's this video that I linked to which describes some weird results of relativity. George is now claiming that this video is incorrect. I haven't yet formed an opinion, hello. Hello.
I can hear me. Yeah, super.
Oh, right. You can hear you. Well done, Bri.
So anyway, we're going to discuss this relativity video, which is it does things like describe what would happen for a long train that was going at the speed of light would actually fit inside a shorter tunnel, which is rather an interesting idea.
This video was one of the videos that made me think relativity is just bollocks, or people don't understand it.
You might have something there.
We must link this video. Let me, because we're talking about this thing, and it's ridiculous if we don't give people a chance to go and look at the damn thing.
Might be a bit late at night to be getting into something that deep now. Blimey.
Yeah, I've got to go say, I'm going to wander off anyway in a minute, but just go and give a link anyway to this thing that people might find interesting if they, as a subject matter. What the hell have I done with it?
George is in the house.
Oh, hello, George.
Yeah, George is here.
Hello.
Hello, George.
Hello.
We were just saying we were just saying that you were disagreeing with this video on here we are, train of Tyrrell paragraphs. That's the one. So this, I'll give the list.
Yeah, the train going over the gap in the bridge.
Yes, I was having a bit of trouble with that. Let's put it in the chat. This is the video that we're having a bit of that George is complaining about, and I must admit this gap in this, which features a very rather a strangely sexy girl, and this gap in the line of a railway line they seem to be suggesting the train could get over this gap as a result of it going really quickly. And I must admit, I was a bit late at night when I examined that, thinking, hold on, is this completely correct? So I can understand why George is a bit annoyed with it.
Can someone play the video?
I could if you like. Okay.
So if you guys want to play it, Con is bugging me here. I'll let you watch it, and then I'll be back in a few minutes or so. I gotta
Okay, I will share
Do
it
something
then.
with Con here. He's not letting me do anything with the computer. He's going to shut it down if I don't pay attention to him.
Right.
Yes.
Okay. Here we go. Here's okay. So can you see the video?
Yes.
Right. And I think actually I probably don't need to play the sound. Actually, I could.
According to Einstein's theory of relativity, Sarah will see the length of this train as shorter due to the fact that from her perspective, the train is moving at close to the speed of light.
What's playing Wagner?
Yeah. So the Wagner seems to be essential. Yeah.
From Sarah's point of view, the train has shrunk, and the
Right. So let's just just make sure. So that's the train is going near the speed of light, and when you see things moving quickly, they appear to you to have shrunk. This is called the Lorentz Contraction, yeah. Okay. So the Lorentz Contraction. So not only does time change with special relativity, but size. So from her point of view, this train
is shorter than the tunnel. From Adam's perspective, the train is standing still, and it is the rest of the Earth which is moving in the opposite direction. Therefore, from Adam's perspective, the train is still at its normal length, and it is the length of the rest of the Earth which has become shorter. According to Einstein's theory of relativity, both points of view are equally valid. Suppose that this train passes through a tunnel. Suppose that while the train is inside the tunnel, we briefly close the doors at the entrance and exit of the tunnel.
Amazing technology.
From Sarah's point of view, the train has
Dean would love this.
and the train is shorter than the tunnel.
Beautifully rendered in 4K.
I bet that nice inside the tunnel without any light.
From Adam's point of view, the tunnel has shrunk and the tunnel is shorter than the train.
Look at the curvature of that Earth.
Yes. So,
although Adam and Sarah can disagree about whether it is the tunnel or the train that has shrunk, they must agree on whether or not the doors hit the train when they tried to close. So, if Sarah sees that the doors did not hit the train when they closed, Adam must also see that the doors did not hit the train. But how is this possible when Adam sees the tunnel as being shorter than the train? The answer is that according to Einstein's theory of relativity, different observers can disagree about whether or not two events happened at the same time. From Sarah's point of view, the doors at the entrance and the exit of the tunnel closed at the same time. From Adam's point of view, the doors did not close at the same time.
This is all about simultaneity, which I can now pronounce.
Hey,
Aristarchus.
drink. Sorry, it's just I can't help it now. It's just a natural response. Problem was last night I got through a bottle of wine without even trying.
Therefore, Adam will see that the train passed through the tunnel without being hit by the doors, even though from his perspective, the tunnel is shorter than the train.
Right, now I think this is where George is going to get upset with it. So I'll start to. Oh no, this is
Now let us consider a different scenario.
I don't get it. Why is the train
The
sometimes
doors
long,
close
sometimes
and
short?
never reopen.
Sorry, say that again.
Sometimes the train's very long, sometimes it's quite short.
Yeah.
Sometimes the tunnel's short.
That's right, but it depends which perspective they're taking. If it's this, so from this perspective, this is, remember, the train is going at the speed of light, and in this, we're in the reference frame of the tunnel. So the tunnel and us are in the same reference frame, which means that the tunnel has got its correct length. We perceive, and the tunnel perceives the train as being shorter. So the problem occurs. So when you see, so they keep on swapping the perspective. So when they show the picture of Adam on the train, they show you the Adam view, in which case the train is at the normal length and the tunnel is shortened. So that's why it keeps on swapping which length is which.
Yeah, my problem is the shadow cast on the building behind the clock has not moved, and the clock hands has not moved, so there's no times changed.
Well, I have two objections on this video until now. The first objection is it tells you the perspective of Adam and the perspective of Sarah, but none of these perspectives are Sarah's or Adam, because it's just a camera that shows from far away. And I'm serious, I really mean it, because he should show us what's the eyes of that human being is seeing.
That's a good point. The camera, this obviously this view here is from. So, yes, they should really have Sarah. Yes, they should really have the view from Sarah here, as in the helicopter looking down here, rather than yes, giving us what they observe. Yes, they should really try and stick, because they're showing us an observer here from a point of view above the tunnel, obviously in the same reference frame. And you're right, they should really show what Adam sees, and they never do that.
Exactly.
So, yes, so you got a good point there, actually, Khalid. That yes, you got a very good point, actually. So that
the second point is the doors. When he explained that the far door is going to close first. This is information. How can I receive information from something that is far before something that is near? So if there's going to be some discrepancy in opening and closing, then I should see the closer door closing and opening before the other one.
Right, now presumably I can't remember, is this the one, I've forgotten now, is this the one in which they're going to close? Are you worrying about them? Are you considering the scenario where they both close in the stationary reference frame at the same time? Is that the one you're worrying about?
No, from Adam's perspective.
Yes, but are you saying from
yes.
our perspective, from Sarah's perspective, are you considering the case when both doors they close simultaneously in her view?
I have no comment on that. I'm just commenting on Adam's perspective.
Yeah, right, but the scenario in Sarah's view is that they're closing simultaneously, and then you're saying, well, what does it look like from Adam's point of view in that scenario? Is that correct?
Exactly. Yeah.
Right. So from Adam's scenario, right? Yeah. Now you'd have to do the calculations. And so what you're saying now, remember, this train isn't going at the speed of light; it's just going at a substantial fraction of the speed of light. So what you're saying is that well, I suppose if you're, we don't quite know where Adam is on this train, of course. If he was let's say he's the driver.
Yes.
Then you're worried. So your point was, reiterate your point, imagining that Adam is the driver in this situation.
Yes.
Restate your point that you made regarding Adam, and you were saying you had a problem with you described a problem you had with the front, seeing something, perceiving the one of the doors.
Yes, that the doors are simultaneously closing and opening in the fixed frame of reference of Sarah.
Right.
And this occurs before after the all right, well, I'm not sure. Yeah, it would depend on where is he on the train.
Exactly, that's why I put it in the cabin.
Yeah.
So right, so you're worried. So okay, let me try and. I must admit, I haven't fully got to grips with this myself either, because I'm a bit rusty on my special relativity. So
you got it good. If he's the driver, then maybe what we saw could be the case.
But you've got a very good point, Khaled, about the fact that we can't have what they were showing with the short tunnel and the long train without being on the train. So that perspective, I suppose like we could have a camera, I suppose, moving along with the train. I suppose.
Yes, exactly.
I suppose you could get away with that then. Yeah, okay. So in fact, perhaps they can get away with that if they have the camera moving along with the train. Then you would see what they show, but they don't make that. Yes, I suppose they're setting the context by saying here we're going to go with the Adam case, which means effectively the camera is now moving along near the speed of light. So I suppose they could get away with that. Yeah, okay, but they didn't make that clear, right? But I suppose okay, I might let them off actually. Right. So in that scenario, what would happen? The door at the front. Imagine he's in the cabin. Then, so I've forgotten what this bloody scenario is now. Hold on, let's just go and check. This scenario is. So is this?
Now let us consider a different scenario.
This is where they close the doors.
This time, the doors close and never reopen, thereby permanently trapping the train inside the tunnel.
Right.
Since Sarah sees the full length of the train completely trapped inside the tunnel, Adam must therefore see the same thing. But how is this possible?
Why are his trousers so tight?
The answer lies
Of all the details to pick up on.
not a rigid body.
Disturbing me.
Yeah.
That is, it cannot be thought of as a single solid rectangle.
I think they should change Adam to Nathan to make him look more stupid.
Instead, we need to think of it as many separate rectangles that are tied together through flexible connections. If the train were a single solid rectangle, then when we applied a force on one side of the train, the force would be immediately felt on the other side of the train.
Indeed.
However, this would mean that we sent a signal instantaneously from one side of the rectangle to the other, which would violate Einstein's principle that no information can travel faster than the speed of light.
Indeed it would.
On the other hand, if we think of the train as many separate rectangles, then when we apply a force to one side of the train, the other side of the rectangle will not know about it until much later, and hence the signal has not traveled faster than the speed of light.
Right. Listen, now this bit I must admit I haven't thought about properly.
If we assume that the doors to the tunnel are unbreakable, then when the train hits the closed door at the tunnel's exit, the front of the train will stop first, while the back of the train will initially keep moving at the same speed as before and stop much later.
Oh, actually hits this. Oh, right, okay. I didn't realize it actually hit it.
This doesn't require relativity. This kind of happen in real life.
Yeah.
In this way, once both doors are closed, both Adam and Sarah will agree that the train is trapped inside the tunnel.
Now, hold on. Whose perspective is this now?
Sarah?
No, because the tunnel's the wrong length for Sarah.
Yeah.
Oh, this is Adam's with his shrinking train.
But no, but it's not shrunk from his point of view. I mean, is this saying...
That's Pete Shee's point of view.
Yet another scenario.
Yeah, I must admit, I don't understand that diagram. And this is the one that George really objected to.
Yes, I hate this one.
That's definite.
Instead of a train in a tunnel, we have a train trying to cross a bridge with a section of the bridge missing.
With some woman standing on there, it's taller than the train, like a 9-foot woman.
She's quite leggy, isn't
From
she?
Sarah's point of view, the train
I
is
think
much
you're being
shorter than
overly
the
critical
section
of this amazing graphics.
and will therefore fall through the hole.
Gravity, that's gravity.
Right, it's gravity. Yes, this is true, though. Of course, any gap that you do have, I mean, if it was a small gap, and
From
you had,
Adam's point of
it
view,
does shrink.
the hole is much shorter than the train.
Oh, sod it, I'm too tired for this. I'm going to leave you guys to it.
Yeah.
Now watch the Giants farmers.
What?
Woman on the right.
Well, I wouldn't call her a giant.
Yeah, they don't.
She's taller than the train.
Sarah saw the train fall
She's
through
just
the
Sarah,
hole.
Sarah.
Must also
It's an equal train.
through the hole.
No, I'm still too tired for this. I'll catch you guys later.
Okay. Yeah, it's a bit,
Bye
bit hard, isn't it? Yeah.
bye. Yeah, I'm not in the right frame of mind for this.
This is
It's
possible.
more white
You
farmer.
can remember that the train is not a rigid
Oh,
object
dear.
and
See you
must
later.
have as
Bye-bye.
many rectangles that
Bye-bye.
are connected through flexible connections.
So what?
Bollocks.
Therefore, Adam will see each section of the train fall through the hole as shown.
Utter nonsense.
I don't quite understand. Yeah, why is that? Oh, Yeah, I must admit, I hadn't. When I saw this, I
In
couldn't.
this way, Adam and Sarah will both agree that the train has fallen through the hole without violating Einstein's theory of relativity.
So much for British row.
Much more
Sarah, the 9-foot woman.
Einstein's
Oh, she's smaller now.
Yeah. So yeah, she had. Oh God. Let's get that sorted. Oh bloody hell! I've broken my bloody. You bastard!
I like these videos, Eugene. This channel, they make wonderful videos.
Right, I must admit, I would have to think about that really hard to try and get that right. I don't fully understand that. But this, yeah, because I don't quite understand why it should shrink, given the fact there was no change in the velocity of the train along the track there. Why should it start shrinking? I don't understand.
Yes, there's no reason. Like the first time when it hit the tunnel, but now there's
It changed its velocity, yeah, and here it didn't. So I'm confused. Yeah, I need to do some exercises with special relativity equations and just to remind myself what the hell's going on. Like I don't have a feel for that at all. I normally have quite a good feel for these things. I'm not getting. Oh bloody hell! Dean managed to get on the Mick West Hangout apparently, according to someone just posted this.
Oh, Mick West on the Flat Earth Do channel.
Yeah, on the yeah.
I have a link to that channel.
Yeah, but but not to the panel though. He made it onto the panel apparently.
Mick West is on there. Yeah, he was talking to Ramsey.
Dean somehow managed to make it on there, according to Rob.
I should have a link in my Hangouts because I'm part of that group.
Oh, I see. Ah, right. Oh, well, Dean's okay. So Dean somehow managed to get a link to that, and he was apparently on it. So he's managed to talk to Mick West. Right. Okay. How did he do? Yeah. Okay. That sounds a bit cheeky. Yes, that's annoying because I quite like to engage with Mick West. I've got a couple of things I would like to say to him. I'd like to talk about that refraction thing because he's trying to do. He's getting to the point where he's almost doing some sort of ray tracing thing like I did with Philip, and he's not quite. He hasn't quite reached the same level of what we could do, but he's getting there. And there's a.
Hey there, Rumpus.
Hey, George, yeah, we've just been through it, and yeah, I'm a bit confused about that gap thing.
Yeah, well, I think this author, Eugene, probably had too many fifths of vodka before he put this together.
He has made, but he's got a huge. I've seen other stuff of his.
Oh
and
yeah, I mean, there's been other videos of his I've watched that were really quite well put together.
Absolutely, and the ideas are really
kind of fell off the cart on this one.
I would be reluctant to say it's bollocks yet. I would have to really. Okay, you're obviously more confident, perhaps. I mean, but I'm not going to commit it as being bollocks yet because I don't have a full feeling for what's going on here.
Well,
I'll be right back. I'm going to find the link for you, Rumpus, and I'll post it in this Hangout.
Oh, okay, thanks.
Well, to properly assess and understand special relativity, you have to, one of the best ways to look at it is look what's called Minkowski diagrams in Minkowski space.
Yeah, indeed.
And the world lines that are associated with what are termed world lines.
Yeah.
And I can't, this kind of caught me off guard, you know, to come in here because I'm really not prepared with any sort of diagram.
Yeah, perhaps
but I could put something together.
Yeah, perhaps we ought to discuss it when we've had a big think about it. And
yeah,
we could do a
I'd like
special or something.
Some diagrams, some visuals, because it really is a visual thing and looking at it both mathematically and conceptually.
Yeah. Yeah,
but I can kind of give you some arguments here without any diagrams why this is BS. At least after the first 5 minutes was okay. You know, described the problem accurately and talked about things properly. But when he started introducing this thing about the tunnel and the contraction, and what's particularly disturbing is this domino nature.
Yes, that's the bit. Well, in the tunnel, it supposedly hits the other end,
and it does,
and therefore slow down.
Yeah,
but I'm not sure it has.
This bunching together of the sections of the physical object is that's where it really falls apart.
Right, that's the bit that I'm having a problem with as well, because because it's not clear. So, for instance, for the Sarah, the girlie to perceive the train to go inside the tunnel completely, there doesn't have to be a crash. It could just see it. The doors could close, and then the train does not have to change its velocity, and it would fit in there. Yet they seem to be implying in this, when they were doing it from Adam's point of view on the train, that they said as it came to a halt, they used the words which implied there was a change in the velocity of the front of the train. So then they seem to be describing two different things. So I'm confused by that.
This whole thing, I mean, the whole problem comes in with how we receive information. You know, we're visualizing and we're having light photons carry information to us. And because those photons come at a finite speed is what creates these problems when the speeds are on the same order with which the photons travel. And then we have this whole problem of what we call simultaneity, where in one reference frame, two events can appear to be simultaneously, like you have two flash bulbs.
I've worked out how to pronounce that, by the way. It's simultaneity.
Yeah, I have a problem pronouncing that. Just
simultaneity.
You know yeah. But anyway, say you have a rocket ship or this train traveling close to the speed of light, and you have two flash bulbs, one on the front end, one on the back end.
Is that you? Something you clicking?
No,
Khalid?
that's not me.
Khalid, you're clicking on the. Okay. Carol.
Yeah, Carlos has a bad habit of not muting himself.
Oh, he's telling me off for that. Apparently, I was typing like crazy yesterday or something, and I got a bit confused by that. But anyway,
I'm not doing anything.
Hey, Carlos.
Oh, you're saying Khalid?
We're blaming you for everything, Carlos. Just suck it up.
Yeah, well, you're breaking up again, Carlos. You've got a bad bloody mic.
I was just blamed for the clicking. I was on mute all the time.
That's better. No, it wasn't you. We were blaming you. Khalid, we were talking about.
Oh, Khalid. Okay.
Yeah, get a different name. Yeah, no, it was Khalid. I said Khalid. You obviously not only was your mic bad, but your headphones were bad as well, obviously, because I definitely said Khalid, unless I'm distorting it.
No, that was my hearing, not the headphones.
Change your Hangout name. From now on, we're going to call you Jim.
Why Jim?
Yeah, so I think basically
it's one syllable, Jim.
Yeah, so I think basically we're going to have to go away and think about this, George, and then if you can make a good case of this being bollocks, then dear, please do, because I must admit I'm having problem. It's a bit dramatic for me to cope with, and I'm just but I'm reluctant when someone who's as established as this guy, and he has made some amazing videos that are about quantum physics and things that are
right.
I haven't fully. He's clearly, I get the feeling he's on a higher level than I am, so I'm a little bit reluctant to just say it looks stupid.
Well, I felt the same way until I saw this, and then I'm going, boy, he sure fell off the apple cart on this one.
Oh, well,
we're not all experts in everything. He might be a bit out of his comfort zone on this.
Was that Carlos saying he was an expert in everything?
No, except for Chris Berry.
That's Chris Berry.
Chris Berry. You're distorted again, Carlos. Bloody hell.
Except for Chris Berry.
Right. Why sometimes are you distorted and sometimes not?
Because when you guys are speaking through the speaker, then it mutes my mic. And then I'm on speakerphone now. Now, if I put my Bluetooth headphones, then it sounds like garbage. I do have a set of regular headphones, but then I have the cables dangling. And
right.
Anyway, eventually I'll get it figured out. Don't worry.
Good, Carlos. It compromises your comprehensibility to us. We don't want that.
But anyway,
when I get home,
what I was trying to say about this is, because we receive our information from light, photons.
Yeah, the Lorentz contraction. Yeah, we know that, George. I mean, we're reasonably familiar with that.
No, but what I'm saying is, you run into problems when the light that we receive for information is coming from objects that are traveling at close to the speed of light. And what I was trying to say is that, say, if you had two flash bulbs, one on either end of this traveling train, and say from the point of view of, what was his name, Brian or something?
Adam, who's on the
Adam on the train. Say he's in the middle of the train, and he has a light switch for both of them, and they're tied together, and he can flick the light bulbs, the flash bulbs, on and off. So if he's in the middle of the train and the train is traveling,
he won't see them coming he won't see them simultaneously coming on and off, indeed, because he's traveling towards one of them, indeed,
and away from the other one. It will not appear simultaneous to him, but as that train passes Sarah, she will see it as simultaneous.
Indeed.
If he flashes it at the point that the train, Sarah's standing at the middle of the train, she'll see the events being simultaneous, whereas Adam will not. And that's where all these confusing issues come in.
So if she's where she is now, for instance, near the front of the train, and he switches them on, presumably she should see the one that's nearest to her first. She'd have to be
exactly.
So she would, not him, her. She would as well.
That's right. But the thing is think about when she's going. There's going to be a point.
Yeah, when she bisects.
As that train goes by her.
Yeah, she's in the middle. She's in the same middle position. Yeah. In which case she would
also,
then get simultaneously.
Think of this in this picture that you have. She's going to see the light coming from the front of the train rather quickly to her, and the one on the back end of the train is going to take a while to get to her.
Yeah, that's the same point, saying if the lights were, she would see the light that's at the one end of the train rather than the other. Yeah, so we covered that. So yes, but there's a point when she's in the midpoint. In other words, when she's in the same position as Adam, as the train goes by and he flicks the switch, she would see them simultaneously. Yeah, so I think that's the point. Yeah, that's the point you were sort of building up to, and I sort of, which you were implying by what you were saying earlier. Yeah.
Yeah. Now though, as that train's going by her, for her to assess the length of that train as the train is going by her, the the lights will not, from either end, will not be received simultaneously anymore, right?
Sorry, I was just doing something. Sorry, George. What are you saying again?
I'm saying she will not have the light being received to her simultaneously as the train goes by her, as it's further, we'll say, down the track.
Yes, if she's not in other words, if she's not halfway between the two light sources, then
Right.
she will not see them
Say the train,
simultaneously.
yeah, say the train is past her, and now when she receives the light from the front of the train will have advanced, and the light now will be coming from the rear end of the train when the train has advanced, and the rear end is a little bit closer to the front end. So to her, it's going to look like it's shortened, you know?
But hold on, it wouldn't matter. She's going to think it's shortened no matter where she is relative to the train.
Yes. Yeah.
But you were you were trying to describe a scenario where she was
Well, yeah, I mean, I got to pick one or the other. I mean,
well, you don't. You can say that for all positions, her positions as an observer, she will see a shortened train. So you imply there was some special case when she was behind the train.
No, I wasn't trying to imply that at all.
Okay, so in which case, yes, generally she sees a shortened train. Well, yeah, we know that. Yeah. So we need to go away and think about this.
And the argument that I use for this, for people to think about, is suppose this train is traveling, very close to the speed of light. Let's say 0.9% the speed of light. So we know that there's going to be a significant contraction, right?
You didn't mean 0.9%, did you? You mean 90%?
Yeah.
Right.
Yeah, I meant 0.9 C, 0.9,
okay.
9/10 the speed of the light.
Right. Okay.
Okay. Yeah. So let's say it's going 0.995 the speed of light. Okay, 95% of the speed of light. Okay.
Right.
Now, we know there's going to be significant time dilation and contraction from the Lorentz contraction at this point.
Yeah.
We could calculate it out, whatever 0.95 squared is subtracted from 1, the reciprocal of that. Let's see. I'll just get that number.
Well, does it matter what the number is, George? I mean,
no, it doesn't matter for what I'm talking about here. But we know there's going to be significant contraction.
Yes.
Okay, from the point of view of a viewer, say, standing on the Earth, stationary with respect to the ground.
As we saw earlier in this video when she saw a shortened train. Yes.
Right. Okay. Now we've got that. Now suppose there is another train on a track parallel next to this one.
Right.
But this train now is traveling at, say, half the speed of light.
Right.
Slower.
Yep.
Okay.
Yep.
Now there's going to be length contraction, but it's not going to be as much as for the train that's at 95% the speed of light, right?
Hello, people.
Hey, Sky.
I'm currently on the Midwest channel.
Oh, are you?
I'll try and find the link to post it to you.
Well, actually,
sorry about the feedback, but I can't turn the audio off.
Okay, Sky. I was going to. Oh my God! I probably was going to go anyway. Actually, but oh God, oh dear! Now I've committed my. Oh, geez. Oh, sorry, Sky. Oh dear. So, come on, George. Before we.
Okay. So, you agree, will you not, that the length contraction
is less than the slow train? Yep.
Let's call the fast train train A, the slower train
can't
B.
we just call the fast train the slow train?
Well, either way.
It's easier to remember then.
All right. So we've got the fast train, we've got the slow train, and then we have the observer standing on the Earth next to the train tracks. Okay. So we've agreed that the fast train is going to have a larger Lorentz factor and more compression, more contraction.
Yeah, we've agreed that.
Than the slower train, right?
Yeah.
Okay. Now, let's look at the two trains. We've got a passenger on train, the fast train and the slow train. But the relative velocities between those two trains is 0.45 C, right?
Yep.
Okay, so each of those will see the other one traveling at 0.45 the speed of light.
Yeah.
0.45 c. So they will see a length contraction that's that's not as great as what Sarah sees standing on the
Yep.
Earth, right?
Indeed. Yeah.
Okay. Now, so let's consider the person Adam on train A.
Slip the fast
And what
train.
does he see?
That's the
He
fast
does
train.
the fast. Yeah, I'm sorry. The fast train. Adam's on the fast train.
Right.
Rumpus is on the slow train.
Right.
Okay. So Adam sees Rumpus's train having contracted by the Lorentz factor given by 0.45 c. Rumpus sees Adam's train contracted by the same amount. There's a symmetry there in the two. However, Sarah sees Adam's train contracted more than Rumpus's slower train.
Yep.
Okay, so here we have a problem given by this Eugene, is if indeed there's what I call physical contraction. That is where your molecules of your body are going to start getting compressed, and you are physically like in a vice getting compressed. How can we have two different compression factors physically occurring? We can't. But yet, that's what he is implying here. Adam's train looks like it's compressing less to you on the slow train than it does to Sarah standing on the ground next to the train. Sarah sees the train being much more compressed than you do. That can't happen. I mean, that's physically impossible, right? And we can have any number of other trains traveling at different speeds, and everybody's going to see everybody else contracting at different rates. You can't have that physically happening.
Yes.
You can't have two different rates simultaneously happening, right?
Yes.
So that's why this is bollocks.
Yes. I mean, I must admit, I didn't quite understand what the criteria of it falling. Well, he was claimed that in the video they claim that it falls down in all cases. So
Yeah.
I'm not quite sure. I'm not quite sure why he was because I'm not quite sure what he decided. The chap who's making the video has decided is the criteria for the train falling through the gap. I mean, he didn't say that the train's this length and therefore would fit in this gap. He never made that. He just simply said there's a gap. And he never actually described why, because you can obviously have a small gap that the train could get over. Or is he just implying there's a length below which it would have got over it? He didn't make that. There was none of that described. So that's what confusing me. He's not saying this is the gap that the train would get over and it's going faster and therefore it's becomes smaller relative to that and then falls through. But I don't think he never made that. He never made that clear. So so that also suggests, I must admit, it is a bit confused. So you could be onto something. I mean, whereas if you're trying to make that point, he would have identified the exact gap and how much it contracted and therefore fitted through the gap. Or because he's not saying that the two are perceiving that it's not falling through, but then I don't understand. Yeah, I mean, I don't understand the gap thing at all, really.
And also part of the problem comes in is how velocities add. They don't add linearly.
Yes, that's the key thing. That's the key thing that we were describing yesterday about what you're doing, how Einstein worked it out at the start. If you were traveling alongside a light beam and then if you managed to get a car, for instance, to go at the speed of light and it turned its headlights on, how fast would the light be going out of the car's headlights? And you can't add these speeds together. And that's one of the crucial things you need to understand.
Well, let's just consider the case of Adam approaching the gap in the bridge, okay? And how he perceives that gap. All right, the gap is coming upon him at his same velocity in the fast train at 9.95 c, right? Both ends of the gap are coming at that speed towards him.
I mean, this is very similar to the question I was asking you yesterday, because let's imagine there was a gap there that could take the entire train. So let's suppose that the train bogies were...
Yeah, well, that's what I'm talking about here. But both ends of the gap are approaching Adam in the train at the same rate, right? At 0.95 C.
Yes.
Okay. Now, what does Adam see? Let's say the instant that Adam looks to see the bridge or the gap, you have two light rays now coming from either end of the gap. Now, if velocity is added linearly, like we perceive for very slow speeds, what would happen is it wouldn't really much matter. The gap would not change size for him.
Well, this comes back to our ruler thing. I mean, if he obviously would perceive
no,
his
but no, I'm not getting it. I'm not quite there yet. I'm saying if velocity's added, linearly, without the contraction factor or without the Einstein addition formula, if they just came, the two rays of light from either side of the gap came to him without a diagram. This is so damn hard.
Yeah, I don't think there is a problem. There is a problem. I think if you look along, if you're in Adam in the train and you look along your train, you've got a ruler with you, as I was describing yesterday, and you measured your train to be, I don't know, 100 meters long, and there's a gap ahead of you that is also 100 meters long. And so the train would fall through it, and you regard the train as a solid object. Hold on, let me finish. Hold on, let me finish. Okay. But you perceive that gap, obviously, because it's through Lorentz contraction, it's coming towards you, is much smaller. So in theory, you might think you could get over it unless you made an allowance for the Lorentz contraction.
But part of the problem comes in here is the fact that the light ray coming from the gap towards Adam is traveling at the speed of light. The train is going towards the gap at 0.95 the speed of light. So that light ray from Adam's perspective is not at 1.95 C. It's, 0.96 or something like that. However, the addition formula calculates it out to be. And so as a result of the fact that there's this correction for the speed at which the light is coming from the gap to Adam to give him that information as to the size of the gap, that's skewed by the fact that there's this addition formula.
I don't quite understand this though, George. I don't know what you're worrying about speed of light, because the speed of light from the two parts of the gap are coming at him at the same speed. It's the contraction, it's the length contraction that's the issue here, not the speed of light.
That figures in because velocity, time, and length are all interconnected, right?
Right, but there's no difference between the speed of light coming at you relative to the atom from either the far end or the close end of the gap. So you seem to be trying to make a difference between the light coming from the far end of the gap and the near end of the gap, and so that velocity is different, and it's not.
But there's a distance that atom is from that gap, and how the time it takes for the light to come from. Oh gosh, how am I going to say this?
I think. Hold on. I think the distance, as you say, is the same for Adam. I mean, the distance between the point A and point B, start and end of the gap. But since he has time dilation, so maybe the time is extended. I don't know.
Yeah, I need to go away and look at my equations and refamiliarize myself with all this to be able to, because I don't have a feel for what the hell is going on here, except that I've got some problems with lengths, sticking a ruler out.
However you resolve it, what I'm trying to say is for Adam on the train, what I mean by his dimensions don't physically change, what I mean is he does not change shape. He does not get squished from his reference frame. He is not changing at all physically at all.
George, this is what you told me 20 times yesterday. I kept on telling you I understood this, and then I had to go because I couldn't take it anymore.
Okay,
I think I'm going to have to go again.
No. Wait, I have a question. Something I need to confirm. If I'm looking at a train by an angle of 45 degrees, right? I see the length of that train 0.7, around 0.7, right?
Run,
Of its length.
Hey, Sky.
put your
Yeah,
email in the back chat.
0.707, you know, the square root.
Yes.
Can't do
Okay.
otherwise.
Now,
Okay,
if
Sky.
if the length contraction for that train, let's say, is half, am I going to see it half at that position and also half when it's passing right in front of me? When
Yeah,
I can
you're
see
always
it
going to see it as smaller, yes.
with the same ratio. It doesn't matter what angle I'm looking at him.
Well, yes, it does. Because the contraction only occurs in one dimension.
So if
No,
yes,
no.
along the length of the train.
I think
Yes.
you will always perceive it as being. I think you will always perceive the train as being the same length. In other words, no matter what angle. Oh no.
You know, like the perspective
Yeah,
where
I mean,
you're
when you
looking at.
figure in all the angles and stuff, you're going to come to the same conclusion that the train is X meters long or shorter than it was. I mean, you just have to figure in all the angles and stuff.
All right.
I think it is. I think I can't justify this completely, coloured, but I believe that it should not matter which angle you're looking at it, because the relative velocity to you.
Yeah, that's right. That's right. You're going to come to the same conclusion about the length of the train.
But hold on, but we answered him differently. Khaled asked much the same question yesterday about something, and we're looking at 45.
Yeah.
No, that was something coming at you. No, that's not. Wasn't the same. The question you asked yesterday was if there was a light source or something coming at you from so there's 90 degrees to your travel, and you asked whether that be contracted, and it wouldn't. So I think we are giving you the same answer now. Yes, it would still the relative velocity to you.
The width of the train will not change, just the length.
Yes.
Yes. So yeah, we are giving the same answer to you, Khaled. So yes, it would not matter what angle you looked at the train, providing the train was coming towards you at a particular speed. All of the train, no matter where you are, whether you're looking from behind it, from the side of it, or the front of it, you would perceive the contraction along the length of its velocity. And if it's something, and you asked yesterday about something that was light was coming from 90 degrees to you. I can't remember what it was, what you were asking now, but it was something about coming from 90 degrees to that travel, and that would not be subjected to the Lorentz contraction. So we are being consistent.
It should, according to what you said now. Whatever perspective I'm looking at the train, I'll perceive the same contraction.
Yes, of the train that's moving towards you.
Well, the thing is, Kelly, what you're missing is it's just the component of the train that it's just the component of that vector that's directed along parallel to the train that changes, whereas the y coordinate that might be perpendicular does not change. So that's what we're trying to get at, is that your perception does change because of the component directed along the length of the train changes, even though the perpendicular component does.
Yes, whereas if you were looking
it does not. That's what I meant. Does not change. The perpendicular component doesn't change, whereas the lateral component parallel to the train does change, and that will be a function of your angle.
And the question you asked yesterday was something that wasn't moving, wasn't moving like the train. It was something you were describing. How would something look? Oh God, I can't remember now what your question was now, but it was different. It was a different question you asked yesterday, I think. But yes, so our
traveler in a rocket would if you look to the right side, will he see the planets squashed in his way?
Right. Yeah. Yes, he would. Yes, sorry. So if you're traveling in a rocket and you looked 90 degrees to the side and you were traveling at 90% of the speed of light, and you looked at a side window, yes, you should see a planet that would not be circular. It would be, squashed in the direction of your travel. Is that the question you asked? That wasn't the same question you asked yesterday.
That was yesterday's question.
Was it? Oh, right. Okay. In which case, okay, if that was your question yesterday, then I think we got that wrong. Okay. Jesus.
Well, I think what we need to do is just report the flat Earth conditions on all this. Is that light is instantaneous and all these problems go away.
They certainly would, wouldn't it? Let's go back to Newton or something. Yeah. Yes, we need to do some work, Card. You're stressing us like crazy with this, and this video is not helping.
No, it's a very poorly done video.
It's your video, not mine.
Sorry, you're right. It's my video that I offered to you as something interesting. Yes, and I only bothered. I was not happy with the last half, but I can't. But this is a guy who made the video who has done some very difficult work, and I'm reluctant to slag someone off or dispute them given that I don't really understand.
I can give you a prime example of a parallel to this. Is William Shockley, one of the 3 physicists that developed the transistor, later in life went into dysgenics and got his ass handed to him.
Is that who's got the T? I can barely hear you of the TV.
Okay, that would be me.
That's the TV. Has to be Khaled or you.
Oh, right, that's not me. It's Khaled. Right. Anyway, I think I'm going to go off and watch some of these. I've got these politics programs queuing up now, and I don't seem able to make
we'll resume this sometime later.
Yeah. So, Carl, we'll try and revise up on special relativity, and perhaps have a special hangout about it, because this is driving me a bit bonkers now.
It's probably going to take several hangouts.
Yes, it will
always a very consuming or a very confusing subject.
Yes, in some ways it's more confusing than general relativity. Though the maths for general relativity is much harder, the implications of that are less troublesome than the special relativity stuff.
Yeah, well, you have a symmetry breakdown because of the acceleration. You have preferred frames, whereas with special relativity, you have this reciprocity, the symmetry that one, reference frame A moving relative to reference frame B, they both see the same thing, and it's contradictory to intuition. How can people in both frames see each other, time slowing down and length contracting?
Okay, well, I'm going to often watch my politics programs before my brain explodes, and so
okay.
We'll have to try and do it some other
time.
Update
me on this Brexit. Like I said, is we don't get much information over here anymore regarding it.
Yeah, indeed, that Brexit. Yeah, well, you can basically think of it now. It's become down to we're now electing a new prime minister. I know you can't do that in the US. You're stuck with the president no matter how bad he gets. But over here,
too bad. Yes.
Yeah, over here, if our prime minister is completely inept like Theresa May, ultimately she can get kicked out. Thank God. So yeah, we don't get stuck with a crappy leader. So yeah, you could do with emulating that.
Yeah. Well, okay. after this administration, there may be some reconsiderations regarding our Constitution.
Yeah. Okay. I will.
Catch you later.
Right. Bye.
Yeah. See you, Cal.
See you. Bye. Thank you, everyone, for hanging out here. Rizzo, I'll check your video, and if you like to hang out and talk about it, then it's fine.